Hello friends, welcome to the class of marketing research and analysis. In the last lecture we were discussing about correlation, simple correlation, multiple correlation, and then we understood then we went into the concept of regression, right. So, we realized that regression is one way of modeling which helps you to predict some outcome or some dependent variable on basis of some independent variables which are the predictors. So, we realized that while calculating the regression coefficients or the coefficients, we realized that we need to understand what the factors like the concepts like the unexplained, explained and the total variance, right. So, I drew a diagram and explained to you in that what do you mean by residual errors or unexplained variance and what do you mean by explained variance, right, and the sum of these two are called the total variance, right. Today we will be moving further and understanding about the little higher form of regression which is called the multiple regression. So, in the simple regression we were only having one variable called the x1, right. So, we were having x1 which was affecting the y, right. So, what we did was we said y is equal to a plus b1 and x1 plus e, that was the basic formula, right, equation. So, a was our intercept, b1 was the slope, x1 was the first independent variable or the only independent variable and ae is my error or we say is the unexplained variance for a. Okay. So, this is my dependent, but what if we are having let us say more than one independent variable. So, let us say y is equal to it becomes b1 x1 plus b2 x2, suppose there are two independent variables, suppose let us add one more b3 x3 plus e, right. So, e is as usual the unexplained part. So, now we are having three independent variables and we know ki every independent variable influences the dependent variable y, right. So, we need to understand, see you need to simply understand what it means. When we are saying y is equal to a plus b1 x1 b2 x2 b3 x3, we mean to say suppose we want to see the effect of x1, right, then what you need to do is just say y is equal to a plus b1 x1 keeping b2 x2 x2 and x3 as constant, right. Similarly, if you want to check individually the effect of x2, then you have to keep x1 and x3 as constant. Suppose you want to see the effect of x3, then you have to keep x1 and x2 as constant, right. So, now, but the equation has become little complicated and tougher because you have three slopes now or the beta coefficients b1, b2 and b3 which needs to be found out and then only you can put forth the values and find out the result, the final outcome, right. So, how do we proceed? Let us go step by step. So, how multiple regression is defined or what it means? Multiple regression is used when we want to predict. So, it is also called predictive analysis, right. So, want to predict the value of a variable based on the value of two or more other variables. So, now this variable is the dependent variable y, right, and based on the value of two or more. So, if it was one it was simple regression. So, now this is my let us say 2, if there are 2 x1 and x2 or it goes up to it can go up to xn, right. So, n number of variables in all independent variables. As it says, is an extension of the simple linear regression. The variable we want to predict is called my dependent variable or sometimes the outcome, target or criterion variable. The variable we are using to predict the value of the dependent variable are called the independent variables or sometimes the predictor, explanatory or regressor variables. Okay. Now, let us take an example to understand. A school master, headmaster wants to know whether exam performance can be predicted, whether the performance in an exam can be predicted of students obviously on the revision time, how anxious the students are during an exam and how much exams classes their lectures they had attended, right. So, this is generally teachers want to know whether there is any relationship between attendance and performance. So, what he can do is when he has three such variables which can affect the performance. So, he says this is he can use multiple regression to understand the effect of revision time, test anxiety and lecture attendance on the performance of the exam. Similarly, another example. somebody wants to predict that whether daily cigarette consumption, right, is based on smoking duration, right, age when started smoking and income. That means, how many cigarettes does somebody consume, does it depend on the amount or the time is one spends on smoking, the age when one started smoking, at which age they started, and what is his income level, right. So, when we are trying to measure such kind of incidents, this is called, this is a simple case of a multiple regression. Okay. Now, let us see this. So, this is my dependent variable, these are my 3 independent variables and my equation looks like this. Okay. So, what are the research questions addressed by multiple regression? Let us see that. For the first question, it says answers is, how well a set of independent variables is able to predict a particular dependent variable, right. How well, how efficiently or how effectively these independent variables are able to predict the dependent variable. Second, which is of more interest to people, researchers, which independent variable, suppose there are 3 x1, x2, x3, which independent variable out of these 3 has the highest influence on y or the biggest influence or is the best predictor. The third question, whether a particular predictor variable is still able to predict an outcome when the effects of another variable is controlled. For example, suppose I want to only see the effect of this and I want to control these 2, right. So, first case I am trying to see this one, and the next case I may take all the 3 and see whether the prediction ability is changing. That means, what we are saying is the change in R square. So, if you remember, we had explained what is R, the coefficient multiple collinearity, the multiple coefficient of correlation, and then we said R square is the coefficient of determination, and we said how this R, what is this R square? This R square is nothing but it talks, it is the, it explains the it is the explained variance, right. So, if there is a change in the explained variance when you take 2 different outcomes in blocks, then we can understand what is the change due to the influence of the other new variables that have entered. So, this method is called a the hierarchical regression method, which I will be explaining you later on. Okay. Some of the assumptions in regression, multiple regression, it is more or less is the same only, but let us see some of them. The dependent variable should be measured on a continuous scale, right, it is the interval or ratio. Assumption 2, 2 or more independent variables which can be either continuous or categorical, right, that is ordinal or nominal sometimes. Now, I will explain what happens in the maybe in next to next class lecture, what do you do when there is a categorical variable, how do you use a categorical variable, right. In the is called a dummy variable regression, I will explain that. The third, you should have independence of observation, that means each observation or respondent is measured only once, right, until unless there is a repetition. The fourth, there needs to be a linear relationship between the dependent variable and each of your independent variables, and B, the dependent variable and the independent variables collectively. So, there needs to be a linear relationship. This is the one of the primary assumptions of regression, or basically in any parametric test, that the relationship should be more or less linear in nature, right. Sometimes I have seen and I have also mentioned in my class lectures that this linear relationship actually improves when you just increase the sample size, right. The data needs to be homoscedastic. Now, what this is also called as homogeneity of variance, right, homogeneity of variance, right. So, then it should follow the assumption of the homogeneity of variance, right, which is generally done through a Levin's test, which I have mentioned here, or you can just check through a scatter plot in the regression or in the graphical charts, right. So, you can just check homoscedastic means it should form a rectangle. For example, if the data, if you plot it on the graph, it should look like a rectangle, right, and otherwise suppose it looks something like this, if the data is you plot looks something like this, it is like a cone or funnel, then we say it is a case of a heteroscedastic. So, it is no more, it is a violation, right. Similarly, the sixth assumption is there should not be any significant outlier, right. Finally, you need to check the residuals are approximately normally distributed or not. This is also can be done through a plots in regression, which is later on we will see, right. So, you can see by taking the standardized residuals and the standardized predicted values, if you take both of them and plot a graph, you will see whether it is normally distributed or not. Otherwise, you can also use the statistic by standard error when you go to analyze in SPSS and go to descriptives and explore and you put the values, right. Then it gives you a statistic by standard error. This ratio should lie between -2 to +2, right. You can find this in my data preparation lecture. Assumption 8 is one of the most vital assumptions, and I will be explaining you in deep. The data should not show multi-collinearity, which occurs when you have 2 or more independent variables that are highly correlated with each other. Now, this is a very dangerous thing, right. The presence of multi-collinearity can really disturb the whole scenario, right, the whole research study. So, let us understand a little bit more about this concept of multi-collinearity, what you should do and how you should clear this problem. So, what is this multi-collinearity? Let us explain. As the name comes from collinearity. So, multi-collinearity is a state of very high intercorrelations among the independent variables. We are not bothered about the relationship between the dependent and the independent. If it is high, it is good, but we are concerned about the relationship among the independent variables. Okay. It is a key issue in interpreting the regression variate. Okay. The problem is one of data, not of model specification. Now, what it says is basically the multi-collinearity problem is a problem of the data, right. So, if the data is so close to each other, that means they are very highly close to each other, then it means more or less you can understand that why should you have 2 independent variables. If they are meaning the same, they are having a very high correlation, they should be use only one of them. Why 2? Because the research says that it should be parsimonious in nature. You should not be using unnecessary variables. You should not be using. You should be using minimum to explain the maximum. Okay. The ideal situation for a researcher would be to have a number of independent variables highly correlated with the dependent variable, but with a very little correlation or little correlation among themselves, that means among the independent variables. Yet in many situations, particularly involving customer response data, consumer response data, some degree of multi-collinearity is unavoidable. Why? Because in social science we have seen, so consumer response data is from social science area, right. So, it has been seen that many of the questions that we ask in social science, they are very close to each other, and sometimes the respondent also does not understand and he feels one question to be like the other, right. So, he confuses or there is a very thin line of difference. So, that is why this problem of multi-collinearity can occur. Okay. Now, let us take this, look at this. A researcher wants to see the influence of hard work, guidance, environment and IQ on students grade. So, what is the dependent variable? Students grade, right, and these are the independent variables. Now, let us see if there is any what is if we have drawn a correlation chart and we see that hard work and its relationship with the type of guidance is 0.937, with environment 0.956, with IQ 0.933. Similarly, guidance with hard work is gone, this is gone, with environment is 0.926 and with IQ is 0.953. Environment with IQ is 0.96, right, and IQ is obviously done with all. So, if we look at this, right, if we look at this, we can see that there is a very high correlation, right, there is very high correlation among the independent variables, right. So, how do you address this problem of what will happen? I will explain you what will happen when you have a multi-collinearity, what happens, right. So, the researcher task includes the following. First, find out the degree, what is the level of multi-collinearity, is it really dangerous or in a very bad state? That means, if it is very high, then it will really have a negative adverse effect on the research outcomes. Determine its impact on the results, that means its impact on the dependent variable. Apply the necessary remedies if needed. If you require to eradicate the problem of multi-collinearity, if it is a serious problem, then you need to handle it and carefully eradicate it. So, we will see. How do I identify? The simplest and the most obvious means is an examination of the correlation matrix of the independent variables. So, what you do is just take the independent variables, draw a correlation, right. Now, by now you have understood correlation. So, a correlation chart, right. So, the presence of high correlations, generally 0.9 and higher, is the first indication of some collinearity. So, I am not saying, or we are not saying here that it is bound to be, but it is an indication that multicollinearity might exist. Okay. But please do not understand that if there is a lack of any high correlation values, that does not mean that there is no there cannot be any collinearity. It is not that true, right. So, it is not a very stringent test. Correlation is not a stringent test to measure collinearity, right, but it gives you some indication. Collinearity sometimes may be due to the combined effect of two or more other independent variables, which is multicollinearity. Now, to assess multicollinearity, we need a measure expressing the degree to which each independent variable is explained by a set of other independent variables. We will look into all of them. In simple terms, each independent variable becomes a dependent variable and is regressed against the remaining independent. I will explain how to do that, how to check multicollinearity. So, multicollinearity is checked by two things. One is called the tolerance, right, and the other is called a VIF, variance inflation factor. In fact, both of them are related, 1 by tolerance, VIF is equal to 1 by tolerance, right. So, this is what. So, how do we check? The first measures for assessing both pairwise and multiple variable collinearity is first tolerance. What is this tolerance? A direct measure of multicollinearity which is defined as the amount of variability of the selected independent variable not explained by the other independent variables. Now, how is it calculated? Now, it is very simple. Take each independent variable one at a time and calculate the R square, right. The amount of that independent variable that is explained by all of the other independent variables in the regression model, right. In this process, the selected independent variable is made a dependent variable predicted by all other remaining independent variables. Tolerance is then calculated as 1 minus R square. For example, if the other independent variables explain 25% of the independent variable x 1, R square is equal to 0.25, then the tolerance of x 1 is how much? 0.75, right. So, let us understand what it means. So, my suppose I have x 1, x 2 and x 3, 3 independent variables. Now, first this is my y is equal to this much, but what I will do is to check my tolerance, to calculate tolerance, first I will take x 1 as my dependent variable. So, what is the equation? A plus b 1 now x 2 plus b 2 x 3 plus error. Second, I will have x 2, let us say I will take x 2. So, what is the equation? A plus b 1 x 1 plus b 2 x 3 plus e, right. The third equation. So, let us find it for x 3 is equal to A plus b 1 x 1 plus b 2 x 2, right, plus e. So, when we do this, so when you are doing for x 1 independently, for x 2 and then x 3, so you find the R square, right, and when you subtract this R square from 1, this is what it tells you the tolerance. Okay. The second measure for assessing collinearity is variance inflation factor. It is calculated simply as the inverse of the tolerance. So, I told you VIF is equal to 1 by tolerance, right. In the preceding example, a tolerance, we had a tolerance of 0.75. So, the VIF was how much? Now, 1 by 0.75. So, that is equal to 1.33, right. So, remember a tolerance value, a high tolerance value lies between 0 and 1. So, the closer the tolerance is to 1, the lower the multicollinearity problem exists, right. Similarly, higher the tolerance value, the closer to 1, lower the multicollinearity. Similarly, lower the VIF, right. That means, if the VIF, suppose if you say my VIF ranges between, let us say it can go to any number, but suppose we say from in between 0 to 10. So, the cutoff value is said to be 10 actually. So, if it is 10, we say still it is okay, but generally researchers have ignored that, and they are now saying it has been said in the scientific community that a VIF value, this value, if it is more than 5, then there is a serious case of multicollinearity or a very high chance of multicollinearity. And just imagine, to have this as 5, you should have your tolerance as how much? 0.2, right. So, that makes it 5, right. So, if my tolerance is 0.2, which is 1 minus r square is equal to 0.2. So, that means you can understand what should be my r and r square, right. Okay. Impact of multicollinearity, this is very important to understand. It has some substantive effects not only on the predictive ability of the regression model, but also on the estimation of the regression coefficients, right, and their statistical significance tests. This is the first problem. A large r square value, sometimes we are very happy as a researcher that we find when we find the r square value to be high, we feel that we have already done an high explanation is very high of the model. So, a large r square values might come, but if you find that the individual beta weights are insignificant, that means the t values are insignificant, then there is a high chance that there is a presence of multicollinearity. That means, if multicollinearity persists or exists, then you may have a very high explanation or r square, but your individual beta weights might come insignificant, right. So, which should not happen in fact, right. Similarly, as multicollinearity occurs even at a relatively low levels of 0.3 or so, suppose, right, the process for identifying the unique effects, that means which when x1 is being checked by keeping x2 constant and similarly x2 is being checked by keeping x1 constant, the effects of independent variables becomes increasingly difficult. So, if there is a multicollinearity, then you cannot understand which independent variable is impacting the dependent variable in which way. So, if that is not done, then the whole idea about regression is, the whole spirit of regression is lost. Okay. Third, high degree of multicollinearity can result in regression coefficients being incorrectly estimated and even having their wrong sign. That means what? You from the correlation matrix, suppose you understand or you estimate that there is a very positive correlation. So, you expect a positive effect, right, of the independent variable on the dependent variable, but suppose the coefficient instead of coming positive is coming negative, then you can understand that there is this is because of the presence of multicollinearity, right. You might have seen sometimes well suddenly one of your independent variables, its beta coefficient is coming negative, but then you are surprised how did it come negative, why it is coming negative. Please go back and check whether there is a multicollinearity problem is existing or not, and very high chance that it must be existing. Okay. And the last is with the addition or removal of one predictor variable, that means one of the independent variables if you remove, there is a large change in the model may become unstable. So, you see how difficult or dangerous it is to have a multicollinearity problem. Okay. So, this is what I was explaining, a common threshold tolerance value of taken as 0.1, right. So, obviously the VIF is 10, but then this is not accepted in the scientific community, right. So, you need to have, at least I have written here, it should be less than 5, right. Correlation of 0.7 can impact both the explanation and estimation of the regression results. Moreover, even lower correlations can have an impact if the correlation of the two independent variables is greater than either independent variables correlation. That means, sometimes the combined effect becomes larger and that can create a problem, right. So, this is what is about the multicollinearity. Now, what is the remedy? How do I clear this problem? First is, if you have a problem of multicollinearity, omit one or more highly correlated independent variables. So, you can see which of the independent variables are highly correlated, right. So, check the ones which are highly correlated and delete one of them if possible. Identify other independent variables to help the prediction. Instead of, suppose you have taken a variable x1 and you find that x1 and x2 are highly related, keep only one of them and bring in a new variable in case you are falling short of variables, right. The researcher should be careful when following this option, however, to avoid creating specification error when deleting one or more. So, you should be careful while deleting your variables. Okay. Second, use the model with the highly correlated independent variables for prediction only, right, while acknowledging the lowered level of overall predictive ability. That means, what it is saying is use the model with the highly correlated independent variables for prediction, that is make no attempt to interpret the regression coefficients. So, if there is a problem, right, if there is a problem of multicollinearity, the regression coefficients do not explain you much, right, the explanation power is reducing, right. Third, the simple correlation between each independent variable and the dependent variable to understand the, so you can simply use what it says is just use the correlation chart and find out the relationship which I have been telling repeatedly, right. Okay. Now coming to, once you have understood what is regression, now we have understood what is multi-collinearity problem. Now we will come into what is the types of multiple regression. I will just wind up this class here, right. In the next lecture we will continue with the both the types of regression, the multiple standard multiple regression and the hierarchical multiple regression, and how to conduct it on calculate by hand, and then how to do it on the SPSS I will explain. But I hope today you must be clear by now ki what is multiple regression and how multiple regression can have help you in understanding the prediction power or the predictive ability of a model, and what are the factors that you should be as an assumption you should be maintaining, and finally what is the impact of multicollinearity on the multiple regression or the entire predictive modeling study of the researcher or the predictive model of the entire study that the researcher is interested. Okay. So, now since you have understood the entire thing about multicollinearity, let us see how to check multicollinearity. I will show you multicollinearity in the SPSS, right. So, I have made a file. So, let us see this is the file, right. So, this file talks about there are which in this we are having 25 cases, and you see there are 4 variables, one dependent variable which is the, you can assume, although it is a collinearity case, you can assume that the strength is the dependent variable, and 3 types of chemicals are being used to measure the strength of, or to have the change the strength or the impact the strength of a product, right, with the 3 independent variables, chemical 1, chemical 2, chemical 3, right. So, now if I want to check multicollinearity, first what I should do is, first let us see just simple, we will do a correlation, first we will go for a simple correlation, right. So, we want to see the correlation between the independent variables, correct. So, we do not want to do anything else. So, nothing simple, I just want to see a simple correlation. So, what I will do is I will go to the SPSS sorry the correlation chart now. Now, look at it, chemical 1 versus chemical 2, there is a very high correlation 0.977, remember it, right. In fact, you can keep note of it. Chemical 1 versus chemical 3 0.488, and that both are significant. This is significant at a 0.01 level double starred, and this is significant at a 0.05 level single starred, right. Now, chemical 2 and chemical 3, right. So, this is also significant, right, but it is significant at 0.498 and at a 0.05 level. So, now we can understand that chemical 1 and chemical 3 are very chemical 1 and chemical 2 are very highly connected or very strongly correlated. Chemical 1 and chemical 3 are strongly correlated, but not so high. Chemical 2 and chemical 3 are also correlated, but not as high as 1 and 2. Okay. So, now let us check, this is only a just a brief glance of the correlation chart. Now, we will go to the model again and check through regression, right, we will see. Now, go to regression and take the strength. So, the strength is our dependent variable and these 3 are my independent variables. Okay. Okay. So, now what I am doing is I will go to statistic, and here I want to check these things, right, R square change, descriptives, collinearity diagnostics, right. Part and partial correlation if you want you can do, otherwise it is okay. My main interest is this, right. So, now look at it. Now, look at the model first. By the model says the predictors chemical 1, 2 and 3, these 3 the correlation multiple correlation value which we have done in the last to last lecture, but there we had called how to calculate is 0.958. So, what is my R square? The square of this, right, 0.919. Now, adjusted R square is something which says that you it will automatically fall down when you introduce unnecessary variables. So, this case this model let us say the overall model is significant and we have a very decent R square value, very high R square value in fact, right. Now, let us go to the this is the area which we are interested in. Now, look at the each chemicals, right. Now, if you look at the chemical 1, so what it is saying, the T value is 3.974 and it is significant at a 0.01 level, and what is the tolerance value 0.046, right. So, we said tolerance value should lie between 0 and 1, right, and the variance inflation factor is 21.63. So, it is highly it is the this there is a serious multicollinearity problem, right. Chemical 2 is again showing 21.3, chemical 3 is showing a 1.329. So, that means what we can understand from here that there is a problem of multicollinearity in this case, but chemical 3 which is the one if you look at the chemical 3, this chemical 3 does not have a show a problem. So, the if you look at this tolerance, it is what it is saying, that tolerance is what 1 minus r square. So, when we are taking chemical 3 as our dependent variable, so and we are measuring the tolerance, we can see that it gives us a very decent tolerance value and says there is no problem of multicollinearity. But multicollinearity is a very high problem in between 1 and 2, and that too we had seen during the correlation also. If you let us go back to the just correlation, you see 1 and 2 there was a very high correlation among them, right. So, this is again substantiated and justified by looking at the VIF, right. So, once you have it, then you can understand that chemical 1 and 2, out of these 2 I can only retain one and maybe I can leave the other, right. So, this is what you do in the case of multicollinearity, right. So, well, I hope you have understood what is regression, what is simple regression, what is multiple regression, and what are the different assumptions involved in it, what is multicollinearity, and how multicollinearity is a very dangerous thing and it can completely distort the whole predictive power of a study, and finally how to check for multicollinearity, and then how you should remedy what remedy you should have for removing this problem of multicollinearity. Thank you for the day. We will meet in the next lecture when we will talk about the different types of regressions, and I will show you how to calculate, and then we will also see how to do it on SPSS. Thank you so much.